All right, everyone, welcome to the 96 Boards Open Hours sponsored by Lenaro right here. We are 17 episodes in. This is the 17th episode, and it is continuing to grow. So that's very exciting for me and everyone that's involved here. We have some people on the call that have pretty much been with us since the very beginning and traveled on through the months, through highs and lows. It's been a lot of fun, a lot of good discussions, and we look forward to keeping this going as long as possible. So traditionally, how does the 96 Boards open hours work? I usually open it up with some announcements, a little bit of possibly things that I might cover if there's not a lot of questions throughout the hour. I have a structured path that I can take, but usually the open hours is going to be season based. So we have several seasons planned out, and I will come on the call. We have an esteemed developer or someone who is participating in the 96 Boards community by developing demos and such. We'll do interviews, and then we will always, of course, take 96 Boards questions. with with all of this said, I know that a lot of you are here because of the announcements that I made on Coursera, and I'm sure a lot of you are here from Coursera. I know that the big the big gimmick was to give away Dragon Boards, and that is what I'm really excited to talk about right now because it's something that's been going on internally with us here for the last few weeks. So the announcements are that yes, we got approval. We have dates. We have a bit of curriculum that will be covered throughout the dates of the open hours that are going to be happening very shortly. And we also have a special guest, and he actually joined this call today. I'm very excited to announce that Lawrence King is here. He's in the call. You can see him there in the video. He's one of the people that was on the team that created the DragonBoard. So from iteration after iteration after iteration, finally ending up at the DragonBoard 410C that you have probably on your desks in front of you from the 96 boards. Maybe we'll give him a second to speak here in just a moment about a little bit about it if he wants. We'll see. But so DragonBoard 410C giveaway, right? We have a 3-episode series coming up, and this is actually going to happen on the following dates. So we will be sharing a calendar post, but I just wanted to let you know verbally what it's going to be. So September 15th is the official date of the first part of the 3-part series, and we will be doing an unboxing of a brand new DragonBoard 410C. So the idea is that you just got your DragonBoard 410C delivered to your door. We want to open it, talk about the components, safety tips, handling it, booting it up for the first time. If time permits, we'll flash a new operating system on there and then take any questions that you have. Lawrence will hopefully be there to take questions as well for anyone in the Coursera course, anyone who's just interested in knowing the process that he went through in developing it, anything that you would like. The second episode of this 3-part series will be a demo, and Lawrence will also be there to talk about his demo. He wants to show us some pretty cool things that he's been working on with the DragonBoard. Hopefully we can please the demo gods and everything will go as planned. And then during the second episode is when we will be taking names. So this is your opportunity to win your DragonBoard. Now, I mentioned earlier before we started recording, Qualcomm has granted us permission to give away as many DragonBoards as the call permits, right? So my pitch to them was that we would like to give away 1 DragonBoard for every 10 participants, which means if there's 50 participants in the call, we can give away 5 DragonBoards. Very cool. So tell your friends, anyone who's interested in the 96 Boards community, working with DragonBoards, working with single board computers, someone that's on your team that you want to develop something with, something very cool that you've been thinking about for a long time, Internet of Things, whatever that comes to your mind that you would like to develop, bring your friends and family in to develop with you and spread the word on the DragonBoard 410C giveaway. There will be a lot of really cool things going on in this 3-part series. Now, so we took your name. There will be competition rules that will be passed out during the second episode. And then in the third episode, this is an exciting one. It's actually going to take place in Vegas. So we are going to have a an audience will be at something called the Lenaro Connect. If none of you have heard of what the Lenaro Connect is, it's a big convention that Lenaro hosts twice a year. Chauvin, I don't know if you want to throw up a link there for the Lenaro Connect registration. A lot of the people here on the call will be attending that convention. There's very, very esteemed keynote speakers. Lots of releases happen during this convention. There's a lot of networking possibilities, and it's heavily catered and a lot of fun. So if you're interested, I would suggest checking out the Lenaro Connect website there. During this, we will have a planned open hours session. We'll have a camera facing the audience, this is obviously, hopefully, camera facing the audience, a camera facing the panel of engineers there. Bring your questions worldwide. We'll answer them right there on the spot for anyone who would like to participate and end up making their footprint here on the 96 Boards community here. All right, that is also when we'll be doing the raffle. So we have your names from the second episode, we raffle them in the third episode. Quick summary is that first episode, out of box, second episode, collect the names, third episode, raffle. Now, to participate, you obviously need to be involved in the second and third episode. If you're not there during the second episode, you won't have your name. Third episode, you won't be called, or you won't hear your name called. We will definitely push out the competition rules. Now, those are my main announcements for the time being, as open hours is meant to be, is to take questions. So did anyone come here with questions? There's 40 people on the call right now. Back when there was 10 people on the call, I would go down the list and just call off people's names. But I don't know if anyone came with any questions around the 96 boards that you have on your desk there, DragonBoard 410C in particular with the Coursera students. There's something on the chat says, do we have to sign in somewhere for the DragonBoard giveaway? Yes. So right now we're working out the contribution. Right now we're working out the competition rules. The rules will usually will include probably filling out a form and providing you with some information such as your email address, possibly a phone number, and then submitting that somewhere. We're still working out the logistics with Qualcomm right now on how we're going to ship the boards to you, because they have a system that allows you to get free shipping and you don't pay any taxes on arrival. So they have a system for this. We're hoping that this works out. Another question just popped up in the chat. So I'm new to this board. What does the Amazon SDK allow us to do in particular? Also, is there a way to connect to Watson? So I've messed a little bit with the Amazon SDK. Now, I don't know if anyone on the call has played more with it than me that could help answer this question. Daniel, are you in here, or would you like to tackle that one, Lawrence? Have you messed with the SDK for the DragonBoard?
No, I haven't touched the SDK for the DragonBoard at all. I've been busy with other things.
No, that's great. That's great. So there is a link that you can go to. It's called Amazon, the AWS kit, Amazon SDK. Right now, I've tried following those instructions. They're a little bit difficult to follow, but they have just been changed, and a pull request was submitted to the Arrow repository to fix the documentation. So as soon as that is updated, then it will be a lot easier to follow for the Amazon SDK. Now, what I can do is I can share some links with you if you haven't been there just yet. So let me get to there real quick. It's under the 96boards.org. You go to the DragonBoard landing page, and you'll have a group of links up there. Yeah, Chauvin just shared the Arrows repository on GitHub. But if you go to the 96 boards DragonBoard 410C landing page, on there on the right side, you'll see middleware SDKs, and then you can click Amazon AWS IoT Kit, or you can click the IBM Watson page, and those will take you to general instruction sets for those. Lenaro did not write any of these instructions, so hopefully that helps you at least get started. And then if you run into any issues, bring them to us next week, and then we can tackle those issues together or post them on the forums at 96boards.org/forums. And that should take you there. Oh, thanks, Siobhan. Great.
We're trying to get Don Harbin to join. He's played with that thing extensively and rewrote the docs. So let's see if he's available. I'm checking now.
Yeah, Don Harbin and also David Griego. They both helped on that. So if and in fact, if you wanted to, you could. Right now, you're showing up as guest 27. But the one who asked the question, let me see. Yeah, guest 27 is that if you want, you can email me, robert.wolf@lenaro.org. And if you come up with any questions between now and next week, I can get David Griego or Don Harbin into the call next week, and we can address those questions very quickly, or we can create a thread and start solving those problems as soon as possible. One more question came from Joe. For the Coursera students, is there a list of sensors and or other accessories we will need? Yes. This is actually a really good question, and this shows up on the Coursera discussions all the time. It also shows up in my emails quite frequently with the professors at UCSD. There is a list of accessories. However, it is important to note that these accessories were collected and decided upon before any mezzanine products existed. So if you're going out there and you're buying all of these sensors separately, well, then you're going to have to go to Amazon or wherever you're living and hunt down these accessories. I did put a bill of materials at the end of course 2 because you don't need these materials other than the DragonBoard. You don't need any of the sensors until the end of course 2 after you set up your development environment. And I also posted this list of the bill of materials at the beginning of course 3. So this includes buying PIR sensors, little single rail amplifiers, wires, breadboards, etc. You get all of your stuff together and you follow course 3 and you build it all out, right? Again, this was before the mezzanines existed. Now we have something called, we have actually 2 of them right here on hand. I have the Aero Linker Sprite mezzanine kit, and then I also have the 96 boards Grove sensor kit. There you go. Lawrence is showing it on the camera there. That's an open version of it. The cool thing about this is that it clips right on top. Here, I'll show you. So I got one right here too. So it clips right on top of your baseboard, and it breaks out GPIOs, I2Cs, breaks out the UART. It also extends your low-speed expansion header here, and it steps up the voltage, right? So you want to start controlling sensors at 3.3 volts, 5 volts. Well, now you can with this breakout here. Not only that, if you buy it in the kit, it comes with a whole load of sensors, right? Now, unfortunately, like I said, these kits didn't exist when we wrote the curriculum. So otherwise, we would have chose sensors based on the kit. But really cool thing is that this is purchased at Seed Studio with 3 E's, SEEED studio.com. You can buy sensors that are compatible with these connectors. So you can literally just go on to Seed Studio, search for the Grove Seed Sensor Kit 96 boards, buy the kit, and then buy a PIR sensor separately. Comes with a little cable. Everything is compatible. You can run the exact same code from Coursera right through this instead. So you won't need to build a lot of the other components. Now in the course, we taught you how to build an amplifier for the heck of it because I thought it was fun. There's still a lot of cool stuff you can do there, right? You don't need these things, but it just shows that we've made things easier throughout the course of since this course was created. Does that answer your question, Joe?
Yes, it does. Thank you.
Great, great. And also Siobhan posted up there the 96boards.org products mezzanine, so you can click on that link and eventually I'm going to start like going like just click on this link, and then I'll go into the YouTube video and edit in a link right here, right? So if I start looking silly by doing stuff like this, maybe that's why. The next question on the chat is, what are the list of accessories one needs to buy along with the board? So is this with regards to the Coursera course, or is this just something that you'd like to know in general? And this is just guessed. All right, dead air. Perfect. So accessories, there is a list of accessories. So you start course 1 on the specialization, the IoT specialization on Coursera. Course 1 is no needed purchases. You just go into the course, you learn about the history of the Internet of Things from one of the esteemed professors at University of California, San Diego, Haranath Garudaji. That's his name. Course 2, we ask you to buy a DragonBoard 410C in particular. You buy it, and you get set up with your development environment. Now, when we wrote this, we switched between Android and Ubuntu. That was the distribution that existed for the DragonBoard at the time. Now it's not Ubuntu, now it's Debian. So it's changed a little bit, but the instructions should still be the same. Course 3, we require you to buy sensors like Joe asked. So at the end of course 2, we tell you, hey, just so you know, get ready for the next course, you need to buy this list of items. And in course 3, you build out certain things, a little LED matrix, PIR sensors, stuff like that. So yeah, and if you forget to buy it, then yeah, you might be bottlenecked at a certain point. Yes, and John just brought up a good point. Don't forget to buy the power supply. A good solution to that is that you can either buy the DragonBoard 410C by itself, and then on the DragonBoard 410C purchase page at arrow.com, you can buy, there's a link to the power supply. Another option is buying the AWS kit. Now, don't be afraid of the AWS kit. This question comes along quite often. Is the AWS kit much different, the Amazon AWS kit much different than the DragonBoard, say, vanilla purchase? The AWS kit is $10 more, but it comes with a power supply. So it kind of compensates for that, and you don't have to search around for a power supply. Okay, Stuart, what is the cost and can it be delivered? I'm guessing that's from Seed Studio. I'm falling behind on the chat here, but the cost of the sensor kit is $69, and yes, it can be delivered anywhere that Seed Studio delivers to. I've only used it to deliver in San Diego, California, United States, so I'm not sure if it can deliver everywhere, but I'm sure there's other places you can find these mezzanine boards. Like for instance, this mezzanine board itself also sells from Arrow, and Arrow has subsidiaries all around the world, so you should be able to find these mezzanine boards in all over the place.
Robert, the AWS kit also comes with Debian pre-installed, so you don't have to reflash it to get Debian. Don't forget that. That is one difference between the board directly from Arrow and the AWS kit. Arrow, it arrives with Android AOSP, and the AWS kit is splashed with Debian. So it is a minor difference, but you can change it to whatever you want. So if you want to get it all inclusive, and particularly if you're going to do development on Linux, it's even saving you time by just picking up the AWS kit.
Yes, that's a really good point, and that question has also come up. So yes, one of the main differences, besides the fact that it comes with a power supply, is that the AWS kit comes pre-flashed with Debian. So you'll have a desktop environment rather than, say a tablet phone environment of Android right out of the box. All right. Does anyone have any questions they'd like to ask in person? There's still a few more in the chat. All right. So guest that says, I'm also interested in possibility of Yocto project for DragonBoard. Well, that's really good because there is a open embedded image for the DragonBoard 410C. In fact, you can find that on the DragonBoard documentation landing page, where we have the pre-built images set up for you to flash, just like you would flash Debian or Android using Fastboot, or you can go build it yourself. I will provide both links right here. This might just take a second, but github.com/Lenaro is where we keep the build instructions for open embedded. And I will go right here. Excellent. So if you want to dive into a little bit of a complex document, building your OE images, your open embedded images, you can go to that document. There you'll find the whole process from start to finish for the DragonBoard 410C and for the high key. If you want to use our pre-built images, you can just go to the 96 Boards website, 96boards.org, and go to / 96boards.org, and then dig your way to the DragonBoard landing page, DragonBoard 410C. And then if you look on the right side, there's operating systems. I'll post this link one more time here. On the right side, it says operating systems. You have an open embedded link there. Oh, that's wrong. That link needs to be changed. So what you would do is you would go to documentation and then downloads, and I'll send you this link right here. We'd go to documentation and downloads, and then you'll have the open embedded link there. You click it, takes you to the pre-built open embedded images. You just download them and then follow the fast boot flashing instructions. All right. So some people joined late. The mini series is going to start on September 15th. Jamon just asked this question. The mini series is the series in which we will be opening a Dragon board out of the box experience. And then our Lawrence King right here, he's in the call today, will be performing a demo on the second part of this series. And then on the second part of the series, we will be collecting everyone's names. And then on the third part of the series, we'll actually be at our Lenaro Connect in Las Vegas live. We'll do a raffle for the Dragon boards. I did mention I spoke with Qualcomm and they volunteered the amount of boards that we need. So the more the merrier. You know, get your development team in here, find the next hackathon you want to go to, and try to win a Dragon board here for development purposes. So it'll be fun, and I think it'll be fun. All right, so what do we got next? Is the Dragon board sold in West Africa? I don't know. This is something that I would suggest going to arrow.com. You can go to www.arrow.com. And from there, you can go to the Dragon board, search for DragonBoard 410C. They have tabs within the Dragon board page to speak to an Arrow representative. From there, you can probably ask them how that will work.
Hey, Robert.
Yes,
just
sir.
I had a thought. Like there's a lot of new people like on this call, and I'm wondering if a lot of those new people might be their first call. I get to talk to you almost every day and hear about the excitement and what we can actually do with 96 boards and all the applications. Instead of like answering questions, if possible, if you could kind of just tell us some of those things. What are some of the usages of 96 boards, and what's kind of the idea behind the whole program? Because it might be some of the people's first time.
Yes. Okay. No, that's perfect. Yeah. So I mean, the possibilities the possibilities behind 96 boards, I mean, are essentially endless, right? I mean, it is the future. They're tiny, they're compact, they're easy on power, and they're high on processing. So what you can develop around the 96 boards is just endless, right? And one of the beautiful things, I mean, in particular, like we're looking at, say, for instance, the Dragon board right now, is that if you develop anything on your 96 board, your Dragon board, those chips are readily available for you to take it right to market. So I know we were just at a hackathon. I was there with Lawrence, and there's these two brothers from MIT that show up. Feel free to chime in, Lawrence. But there's these two brothers that show up at every one of these hackathons, and they develop these amazingly cool projects. The last one that they did, they took a Bluetooth module, and then they had the Dragon board as a hub, which was running a camera. It was running several other interfaces. And then as soon as this Bluetooth module got close to the Dragon board hub, it would trigger a timer that would then start ticking up a cost that would be linked to a camera and your smartphone, so that you could monitor from your iPhone your car that's in the parking spot. So it was a parking app, right? But I mean, these are you have infinite connectivity. You have Wi-Fi, you have Bluetooth, you have GPS. Everything is intertwined together, and then you can develop anything with that from that point on. Push it to market very easily. I don't know, Lawrence, you want to chime in on this one?
So one of the differences between Raspberry Pi and the DragonBoard is Raspberry Pi. You can buy Raspberry Pis. They're really cheap. A Raspberry Pi 3 is pretty close to performance of the 410C, but you have no path to production. You can't buy chips from Broadcom, and no matter what volume you're in. They're Raspberry Pi only chips, so you have to buy Raspberry Pis and embed Pis into your product. Whereas the 410C, you can buy all the chipset, all the associated chips around the board, and build your own customized board with any additional peripherals you need from Arrow. So there's a path to production when you use the DragonBoard that you don't have if you use the Raspberry Pi.
Yes, yeah. So exactly, the path to production. That was one of the main points that I think is perfect. I mean, like if you develop something on a Raspberry Pi, well, you're stuck putting that Raspberry Pi in every single one of your products that ships. But you develop on a DragonBoard, you can then design a SOM, system on module, around the chip, and then buy 1 million chips or buy 10 million chips and then profit, right? Everyone makes money. It's the goal, right? You want to get your product out there, and it's very easy, very straight, very easy to do with these chips being available, unlike other boards. Yeah. So, did that answer? Did that get a little bit going there for everyone? You got kind of a comparison. Also, people always compare the DragonBoard 410C to like an Arduino, and you can't really compare it to an Arduino. On top of the fact that you can even use an Arduino with the DragonBoard or with your 96 boards. So we were showing earlier this little board right here, the mezzanine, sensors mezzanine. If you look closely, I can't see my own camera here, but if you look closely, this little chip right here is an Arduino, right? So it's like, why do I want to use an Arduino over a DragonBoard? Arduinos are simple. They can do menial tasks. But when you want to perform something heavy, you're gonna need something more powerful. And then you can offload all these little menial tasks to the Arduino. You have access to the Arduino pins right here, the little blue strips. So everything is there, and then this just clips right on top of your DragonBoard. And this is actually really cool because I think Lawrence is going to be showing this demo and demo using this board, the Arduino and the DragonBoard, on the second part of the series, coming up in a few weeks or a couple weeks.
Yeah, Robert, there's some other things too about developing on 96 boards. If you use the libsoc or MRA libraries to develop your application then becomes portable across the entire 96 board family. So right now there's the DragonBoard, there's the Heike board, there's the Bubblegum board, there's an SD 600 eval board, all of them using different SOCs, some from the same vendor, Qualcomm, some from different vendors. But by using the libsoc library and the MRA libraries, you can write code and then compare the different chips and figure out as you're moving forward. For certain applications, you may want to use one set of chips. For another application, you may want to use different chips. But you can use the same form factor. Your mezzanine boards remain compatible. You can test with the same code base without having to rewrite code, without having to go completely crazy. If somehow in the future a board gets obsoleted as new boards come out a year, 2, 3 down the line, depending on the boards you're looking at, your code remains compatible in the 96 board family. So that's a whole massive difference between looking at the Beagles, the Beagle Bones, the Beagle Bone Black, Green, Beagle, the whole family, and the Raspberry Pis. As they changed versions of the Raspberry Pi, the connectors changed. As the Beagle family changed, they changed connectors. Now they've somewhat standardized in the Beagle Bone Black and Green connectors, but not completely. So this is one area that's really different about the 96 board family as opposed to the other typical low-cost single-board computers out there. And that's a really big deal when over the long haul, not just talking 6 months, but talking years. That's a big deal. As Qualcomm comes out with future 96 boards with other chips on it, there's compatibility there. So it's a really big deal for those developing products.
Absolutely, absolutely. Um, the the perks of using 96 boards, again, I'll also kind of go into the whole. It's kind of endless, right? I mean, you have this vast sea of boards to choose from, right? But 96 boards is something that allows you to kind of spread across, like David said, multiple SOCs. So, I mean, you're not limiting yourself. Did you want to chime in, Daniel? Saw you kind of like something you popped up. Okay, cool. Real quick, there's a few questions that surfaced here. I just want to get them answered real quick. Joe, what are the considerations for running DragonBoard from a battery? I mean, as long as you match the voltages and currents, you should be fine if you're doing DC. Otherwise, I mean, I run my DragonBoard off of an inverter from because I mean the plug will regulate the voltage and the current. Um, so if you have something hooked into a battery, so like my systems have battery, charge controller, and inverter, but you could essentially have a battery hooked, an inverter hooked into a battery, and then you can just plug your 96 boards right into the inverter. Or if the battery matches, or the circuit that's hooked into your battery matches the voltage and current requirements of your DragonBoard, then I would say you should be fine. Lawrence is a big hardware guy. I don't know if he wants to correct me on that, but
I'll sort of
before
chime.
Lauren,
Okay, go ahead, David.
You take it first, Lawrence, then I'll jump in.
Okay, the 96 board spec was written so that the power input connector is very wide range. It'll accept anything between 8 and 18 volts. So typically you would take your 11.4 volt battery pack or your 12 volt lead acid battery in your car, or almost any battery pack that has enough voltage, connect it to the input connector, and the board will run. It is not really fussy, unlike some of the other single board computers out there that need really clean 5 volts from exactly the right supply, and if you don't get that, the board crashes. The 96 board spec was written knowing about that issue and making sure that it worked really well. The 410C extends that 96 board spec a little bit. The 410C will run right down to 6.5 volts, so you can run it off a 7.2 volt battery pack also. You do not get battery charging on the 410C. You'll have to add your own battery charger externally. And the 410C was not optimized to minimize power consumption to the lowest it can get to. Some things are left turned on all of the time, so you may not get great battery life out of a small battery. But I used an 11.4 volt battery pack from an RC race car, and it runs for about 48 hours on a charge.
Yeah, adding to what Lawrence just said, I mean, this thing was designed so that if you, for example, doing robotics, depending on the motors you're using, you typically have very large batteries to drive motors. And those batteries, depending on the motors you're using, they may be 9 volt, 12 volt, they may be 18 volt. It really varies. The beauty is, since you got to have big motors for robotics, for example, to keep your robot running, and the motors typically are the biggest power consumption, you can just tap right into that same supply without having to step it down and regulate it to a 5 volt or other things. So really, that's the kind of target here when they thought about the spec, is how to make it easy to use no matter what kind of power you were using and what you would be likely to see on standard battery packs. So that was kind of the thought there.
yeah, and like I said, I mean, I've been running so Lawrence has been running his DragonBoard. I've been running my 96 boards off of my battery pack kits. I've never messed the board up so far yet, as long as you keep it within those ranges that Lawrence was saying. And you can see these specifications that he's talking about on the 96 boards GitHub. There's the specifications are uploaded there in PDF form. I'll just share it real quick one more time here, but you can check those specifications out so you can see all of the things he's talking about. Real quick, Gerardo was asking a question about Ubuntu and Debian. And in the course, we were talking about Ubuntu because that's all that existed back when we made the Coursera course. But now it's moved away from that, and Debian is pretty much the main Linux release there. You can find the Debian downloads there where I just posted. You go in there, you download the appropriate images, and then you proceed to the installation page where they will show you how to flash them. I saw a really cool question here, actually, and I'm curious about this question, and I think Lawrence is the perfect one to answer it, hopefully. But what type of environments can these boards work in? So, for instance, hot, cold environments. Like, also, he said, what about EMF fields and interference? So, is this a
Okay, I'll start with the EMF fields and interference question. Of course, the board has Bluetooth and Wi-Fi transmitters on it, so it is transmitting in those unlicensed bands. So if you have something that's sensitive to that, then yes, it will cause a problem. The board has been FCC certified. It does not emit unintentional emissions. It is, I guess, clean enough to pass FCC as a consumer device. The second one is you asked about the temperature range. The board itself was designed to run from 0 to 50 degrees C, which is, I'm going to call it, pretty standard for consumer devices. Anything that's sitting in your office will be fine. The Qualcomm chipsets themselves will run from -30 to +85, but in order to get your board to run over that range, you need to ensure that all of the other chips on the board are also specified for that range, so that you would have to design your own board if you wanted to get wider ranges. There are some people who want even wider ranges. They want to go from -40 to +125. The Qualcomm chipset is not qualified to do that, although it may run. It's not formally qualified to do that.
Good. Thank you, Lawrence. I hope that answered your question. Was it Stuart that asked it?
Stuart came up with a follow-up question, which was whether the board could be adversely affected by EMF fields. And again, FCC testing also verifies the board can withstand a certain amount of hostile RF, subject to anything that Lawrence wants to add.
That's correct. So it does withstand some hostile RF. The GPS receiver is particularly sensitive to any hostile RF, and you'll often find that in poor environments the GPS won't run. But GPS is at best hard to get running for anybody, so don't expect wonderful performance out of the GPS.
Yeah, at the very least, you'll need to be in open, clear skies, outside, running off of a battery pack, and in ideal weather. Cool. There's another question here is a pretty simple one, but will you send out an email reminder about the mini-series? And the answer is yes. In fact, I don't know, Siobhan, we have a mailing list, right? Is there any way we could share that the link to the mailing list? People can join the mailing list. I'm not sure if that was created yet. We will be sending out on Coursera. Jamon, I'm not sure if you are a Coursera student, but if you are a Coursera student, I will be sending out an email again to all of the 6 courses within the Coursera, and then you'll be able to, I would suggest following 96 Boards on Twitter, twitter.com/96boards. There you can find out more. We post things all the time on there about OpenHours. It's one of the main things that gets posted up there right now. And the mini-series, Vav. So the mini-series on September 15th, we're starting a 3-part mini-series. It's going to involve the DragonBoard 410C unboxing experience, some demos from Lawrence King, which is one of the main team members from the people who created the DragonBoard. And then on episode 2, we'll collect a bunch of names and raffle off a bunch of DragonBoards. So it's your opportunity to get your hands on a free DragonBoard. It's also your opportunity to learn a whole bunch of really cool stuff and get access to some resources that will only be shown for the first time during this mini-series. So I would suggest checking it out. Great. Any more questions going on here? Siobhan just posted up the mailing list, 96boards.org/openhours. Oh, okay, perfect. Don Harbin's here. I just saw him pop up. We had a question earlier about the AWS kit. Don Harbin is the one who was working on that with another developer at Lenaro. And is there any way that we could share the new documentation, Don? Do you have access to that? Has it been accepted into the Arrow upstream yet?
Hi, Robert.
Hello.
No, there's a pull request going for the main one, but I can share the site where the instructions are in the link if you'd like. It's just waiting to be merged.
Yeah, that would be great if you wouldn't mind.
Yeah.
Don Harbin is one of the developers here at Lenaro, and he went through some great efforts with another developer, David Griego, to help better the instructions that already existed. You won't find these anywhere else except under this GitHub repository, which is github.com, Griego /AWS.
Yeah, so really, and really all you need to look at there is just the README. It just gives you the instructions. It actually points to Arrow's GitHub, and it's just waiting to get merged in. And the only thing that'll be merged in is a new README that just makes the instructions easier to follow, and they work. And then, and the demo itself, I just brought it up before I got in, so it's actually running right there. You just have to go up and select the right thing up in there, and then I could share my screen real quick if you want and just show it. It's pretty basic.
Yeah, and people were wondering what exactly it was, what you could do with it. I mean, it was pretty cool. I was playing around with it. He's putting this link earlier.
Yeah, so it's pretty basic. Tell me when you can see the screen.
We can see it.
So if others could get on there too, I mean, you can push the on and off button and it would light the LED. So this is a 3-bit wide end-to-end AWS sample. So it's not real big, but what it is a framework. And so if I go over and hit the volume button on the DragonBoard that's on my desk, you can see the events happening in my terminal window. And then you'll just see those kind of get toggled and shown on the web through AWS. So it's kind of an end-to-end experience there. But like I said, it's really just 3 bits, 2 out and 1 in. But what it's doing is giving you the framework or a starting point where you've now proven you've got an end-to-end solution working on AWS. And now you can go, add a lot more complex things if you desire. It's a great starting point.
Great, yeah, thank you. I remember taking a workshop. Actually, I got to see only a portion of it, but yeah, the idea is that you have the AWS cloud, you have your DragonBoard, and then you have another component. And so what you do is you send the information up to the cloud then pings the other component, or vice versa, and then you're able to like he said, you can go to that website, toggle an LED on his desk, right? So it's pretty cool. And that's all the instructions that he helped right there.
Right. So
ooh, okay. Yeah, thank you, Don. Appreciate
sure.
that. So we're getting close to the end of the hour. There's one more question up here. It says, someone said, I saw DragonBoard being used in a Google Home automation project. I'm assuming this is the Google Home automation project that I've done, and this was written, I believe, by the Qualcomm Think-A-Bit. I actually have this. It's pretty cool. The Qualcomm Think-A-Bit lab on the campus here in San Diego. I'm assuming, and it's a lot of fun. Can you use the DragonBoard as a data acquisition and actuation device? I don't see why not. I mean, I would say yes.
Absolutely. I use it as a control for my sprinkler system. I use it as a control for various relays. I acquire data both from the GPIO and I2C. It's absolutely a data acquisition and control device if you want to use it that way.
So the other part of the question was about RTOS, and real time is, it really depends on your definition of what real time is. If you're thinking that you can open and close your garage door, you only need response time in the 1 second range. The DragonBoard in Linux is plenty fast enough for that. If you want things that respond and guarantee response in the 10 microsecond range, then any board running Linux will have difficulty with that, because Linux may choose to reschedule some of the other things it's doing. So as far as porting a real-time operating system to this, I haven't seen that done. I haven't looked at RTXi as an example, or any of the other ones, but I have heard of people putting the real-time extensions into Linux onto the DragonBoard, and they're supposed to work, but I haven't tried it myself.
May I suggest an alternative to a real-time operating system?
Of course.
I think using an RTOS is a way to try to work around hardware weaknesses. A much better idea would be to use the Arduino on the sensors board, because the Arduino is a microcontroller which is on a timed loop. And a timed loop is what you're looking for if you need as long as it's fast enough, if you're looking for those sub microsecond even response times, where a computer which is running software and has lots of things going on is just that. It's a piece of hardware that achieves a lot of things. That's why you want to pair a microcomputer with a microcontroller if you need the real-world interfacing sub-second response times. Using an RTOS is a hard way to try to accomplish the same thing.
Yeah, that's a very true statement. And if you pair like the sensor board with a DragonBoard, you can program the Arduino to capture things on a real-time basis or actuate things on a real-time basis, and then report that back down the UART link back to the 96 board to gather the data and transmit that back to the web or wherever you might want it, so to speak. So, yeah, it's a good solution depending on what you're attempting to do.
Yeah, so Yang brings up a good point. If you have any questions about Xenomai, Jorge's in the call right now. Thanks, Mark, for that too. I wish more people would speak up. the chats, but did you want to talk a little bit about Xenomai, Jorge?
Yeah, I don't know if people is interested, but at the end of the day, if you really need real-time responses, you either need to use a PreemptRT or a microkernel with Xenomai or RTII, one of those solutions. There are a number of acquisition systems, since someone mentioned that they are using Xenomai when they want to capture high-frequency signals on a number of channels. When they don't enable Xenomai for that, they start missing samples and the system misbehave. So it always depends on what you need. If you're going to be acquiring signals at a low speed, then you're fine without not doing any patch. I think Linux will give you something like by default, what was it, 500 milliseconds or something like that, roughly. That's kind of safe. But if you want to go into microseconds, I'm talking about 50, 60 microseconds, then you certainly need a real-time patch on any Linux system. If you enable PreemptRT, you get to 40, I think, 40, 50. If you enable Xenomai with a co-kernel, you get maybe a little bit better on 86, certainly better on ARM64. But again, it depends on what you need. All I was sharing here on the chat is an example of some acquisition systems that I'm aware of. And that's all. I mean, I did a port of Xenomai to the DragonBoard a few months ago, actually many months ago, but I couldn't keep on porting to the subsequent DragonBoard releases because the DragonBoard kernel follows mainstream. So it's following upstream, so it moves very fast. And Xenomai is not in the kernel yet. But there's a plan to upstream Xenomai to kernel.org. I don't know if it will happen. In the meantime, it's just we support Xenomai supports 4.1. We'll support hopefully 4.4 soon, but we cannot develop at the same speed that the kernel is moving. So that brings an issue. I don't know if you have any questions. I'm glad to help.
Yes, and that being said, I'm not sure how many of you are aware of our IRC channel, but we have an IRC channel where you can also get, for the most part, real-time responses throughout the week, not just having to wait until open hours. You can go to the free node IRC. In fact, maybe I should share a link to an easy way to access it. But Freenode IRC, you can join the 96 boards channel there, and you can talk to Jorge, during his Freenode IRC. Is this the place?
My IRC?
I'm trying to find. There we go, right here. So Freenode IRC, you can talk to LDTS. That's his handle. But if you go to that link right there, which is webchat.freenode.net, and go to #96boards, you will have access to a whole nother pile of resources there, which is just a chat room full of developers to help answer your questions. And as well, obviously, the forums, right? So Daniel Thompson's here. Akira usually joins the calls, but feel free to go post your questions on the forums anytime as well. Those things get answered pretty quickly too. Looks like the answer about the TV board got posted up there. Yeah, the specification is there available now too. Any more questions here? I feel like this was a really good call. People are getting some good stuff out here. Thank you, Joe. Appreciate your participation, man. Hope to see you again next week. Yes. Gerardo, you usually come with a question. John Mark, what about you guys? How you doing? Some of our frequenters. Mark, look forward to seeing you at Connect.
Yeah. Okay. Sorry. Yeah, I'm doing fine. Thank you very much, Robert.
Hello.
I was just concerned before with the mezzanine about about the connectors, but I found all the solution by myself. So
okay.
I sent 3 times the question on the chat, but this too easy question, I guess. So anyway, I was wondering about the mezzanine. Let's talk about the mezzanine very quick. I'm very interested about the mezzanine, but I didn't know where to find these connectors, but I found them. And now the second question: if I'm running Android, can I handle the mezzanine without any problems?
Yes. So
I don't need to run Debian.
You don't need to run Debian. I mean, you can access the low-speed expansion header from Android as well.
Oh, okay, fine.
If you're running the DragonBoard, the GPIO values do change.
Sure. Okay.
They're offset by 902. We've talked about that a couple times. But in general, it should work the same way. I mean, you're just pulling everything up from the low speed and then sending it and breaking it out.
So it's transparent.
Yes.
Almost. Okay. Thank you very much. Okay. Thank you.
This question actually came up on the forum recently. Obviously, if you want to program the AVR, you have to do quite a lot of hacking to get AVR Dude up and running. Which in principle you could either compile as a Bionic component, or you could put it in a chroot and run a chroot to get your programmer going. But if you actually want to recode anything running on the AVR, things will get a bit more complicated. If you're just doing basic I/O, I2C, and perhaps talking to a firmware that's already on the AVR, then it's very easy.
I understand. Okay. Yes, I was more interested about that than using the AVR anyway. So thank you.
In terms of a development environment, there is a programming header for the AVR on the top of the board. So the simplest thing to do is to get a cheap AVR programmer off eBay, drop that onto the development header, and then you can recode that from your workstation and then talk to it. So the serial link between the AVR and the main board simply needs to just be the commands you're sending it. And then you don't have to worry about programming or anything complex running in Android. You can have your development environment entirely separate.
But you can program the AVR. AVR, you mean the Arduino? You can program it directly through the micro USB. Is that right?
Yes. I've never done that. I didn't know you could.
Yes, you can. You can program it directly through the micro.
The mezzanine is almost a standalone board, so that could run by itself as well.
Yes.
No, that's new to me. How did you do that then?
No, you can do that. I read that one someplace.
No, I've done it. I've actually done that. You can either program it through the DragonBoard without a micro USB, or you can program it directly. It needs the power from the low speed expansion header, but you can still program it from the micro USB that's available on the directly to push. You can push Arduino sketches right.
And I
there.
guess you will be able to use the Arduino IDE in that case.
So I was unsuccessful with the IDE.
Not bad. I thought the only way to do that was to short circuit the UARTs on the low speed connector.
Right, it's what it is. So you should be able to run an IDE. It's too much stuff on these Dragon boards. Too much stuff to be able to do. So.
Okay, well, just to let you all know, Lawrence will be going over some really cool stuff on the second part of the series. He's actually going to be using the Arduino on this board, and I'm pretty sure he's going to be sharing all of the source code from there as well. But the only thing I've done is I've plugged this directly into my DragonBoard. I've connected right to the micro USB on the mezzanine, and then through the terminal, I've pushed sketches onto the Arduino. So through the terminal.
What that's doing is that's the micro USB connection is talking to the DragonBoard. You're then running stuff on the DragonBoard to reprogram the AVR using the other UART on the low speed connector. That's how that's achieved. And when you put Android on the baseboard, it is now difficult to run AVR Dude on the baseboard. Not impossible, just awkward. And that's why I'd suggest using external programmer, because once you put Android on the baseboard, it's not that you can't do it, but it gets fiddly trying to get things like AVR Dude and the AVR C compiler running on it. It's not that you can't do it, it's just unnecessarily fiddly for the sake of a £10 programmer.
Yeah, that makes sense. I mean, another option would be if you want to program the Arduino and that's it, you could have two Dragon boards or two 96 boards, program your Arduino and then plug it on top of program the Arduino on one running Debian and then plug it on top of your Android board to have it. So buy more 96 boards. Just kidding.
Yeah, that's nice, but it's cheaper to get the 10 pound programmer.
Yeah.
That's why we need the giveaway. That's why we need the giveaway board to have all those Dragon balls.
Yes.
There you go.
We will be. In fact, actually, it's pretty cool. I've been talking to Chauvin about this, but obviously for the people who have been here so long, we do our season. Then we have right now we're in the break time, and then we're going to do another season. And during the season, we do interviews, like really cool interviews with developers all around the world. It's very fun. But during the next break, I think we're going to be doing giveaways for one of our other 96 boards. So maybe we'll be doing giveaways for High Keys or Bubblegums or MediaTek boards. You never know. Maybe we'll be doing mezzanine board giveaways. This is still up in the air, but I was talking to Chauvin about this, that it's a really cool thing to do during the breaks. I just wanted to address this really quick. It showed up on the chat about the chat log that a lot of stuff has happened in this chat log. How will you guys get access to it? Well, someone in Lenaro, her name is Jennifer. She actually has been very, very cool and hard at work. She watches these videos after they're done, and then she logs everyone's questions and puts the time in the video and puts the question and in the description of the YouTube video. So it's very cool. She'll probably be doing that for this, and then she also includes the chat as well. So the chat won't be lost. Everyone who posted in there would like to see it. Are there anything else going on? Qualcomm InventOff series should give you some inspiration. Yes. I'm not sure. I haven't seen the last episode. Did they air that yet? The last episode? Episode 5. So there's one more episode to come out. I already know the winners, but I'm not going to say. Yeah. Cool. Well, if that's the case, if there aren't any more questions, I'm just going to close this out with some last announcements here. And a few more links. So for those who were here last week and got to listen to David Mandala speak, and you want some reading material from now until next open hours, that was his blog from last week. Pretty cool. Command line remote debugging. We're going to be pushing out a new blog. He will. regarding remote debugging using Eclipse, and we can talk about that next week. And then there's another blog that we just pushed out for a workshop that I did at Qualcomm campus for the DragonBoard. So you can check that out. There's a video and a slideshow kind of getting up and running with your DragonBoard 410C. Arun, what's up? You got the floor. What are the debugging options? Well, I think that's a question for David. What's up? What do we got? Is it GDB to DDD?
Well, right now you can do GDB on the board. You can do GDB server and GDB multi-arch and do remote debugging on a Linux system. And you can use DDD on top of that, so you can get a GUI. And I'm in the process today and tomorrow of writing the new blog, which will let you use GDB server, GDB multi-arch with Eclipse on a Linux system, a remote Linux system, and use the Eclipse debugger to launch everything, and also to be able to remote run the software through the Eclipse interface. The Eclipse, I have to admit, the Eclipse debugger interface is quite nice. Eclipse has kicked my tail for 3 weeks to figure this out. When I will, in the blog that I'm writing, I will highlight the things that must absolutely be done in specific orders, or it will look like it will work, but it will absolutely fail to work. And there's a couple bugs that I'll be filing with the Eclipse organization, because there are some real oddities with Eclipse on this. Apparently the remote development plugin for Eclipse has a few special features that interact interestingly with regular Eclipse. At any rate, I've now kind of sussed it out through the help of a couple of guys, which I'm going to give credit to in the blog entry. And we will get this blog out. And like I said, the Eclipse debugger interface view is really nice. I have to say, while I'm not personally a huge fan of IDEs, my IDE is my text editor, and Make. But while I'm not particularly a huge fan personally, I have to say, after sitting down last night and getting this thing running remotely, that interface was quite impressive, and I can see the value why some people really like it. But I will also say, don't do it on a small 720 window. Eclipse is a view hog. You really want to be on 1080p or a 4K screen. That thing is immense in its display. But at any rate, it'll be all documented this week, and by next week it'll be on the blog site, and you can get it running. It's pretty cool.
Cool. Thanks, David. Yeah, so we have Jorge on the call right now, right? And hoping to have him come back next week. We were just kind of curious. I don't know if anyone would be interested in hearing a little 10-minute section on kernel virtual machine, KVM. So I don't know if anyone would be interested in hearing that. We can have a little 10-minute talk next week. What do you think, Jorge?
I'm okay with that. If people is interested.
Great. I think that it would be good regardless. Putting this up on YouTube, people can have the opportunity. It'll show up in the description. Pradeep just said +1. So yeah, if you wouldn't mind giving us a little 10-minute section next week, that'd be great.
Yeah, good.
Great. One other thing before I do my closing announcements. Of course, questions can still pop up, and we might stay here longer. It's up to you guys. But I needed to check with Deepak, right? Deepak, you got my email. You were able to send an email to the thing I gave you to get your DragonBoard?
I'm going to do that, Robin. Thanks for the information.
Great. Yeah. So Qualcomm already has all of your information, but they need you to send it to that website so that they can ship it out to you.
Sure, I'll do that. Thank you very much.
Excellent. That's a new background for you. You at work?
At my workplace.
Oh, nice. Cool. All right. Well, then I would like to close this out by thanking everyone for your attendance and for your great questions, for showing your support to the 96 boards community and the open source community. It's great to have so many return people last quick announcement would be that don't forget the mini series on September 15th. We will be having 3 episodes consecutively, Thursday after Thursday after Thursday, starting September 15th, where we will be doing a DragonBoard 410C out-of-the-box experience, followed by a nice demo from the DragonBoard creator, Lawrence King, in the second episode. We will then take down names following a competition rules policy for a DragonBoard 410C raffle, by which we will be giving out a bunch of DragonBoards to everyone participating in the calls here based on a raffle experience during the Lenaro Connect in Las Vegas, live in front of a bunch of people. So it should be a lot of fun. Again, thank you for attending the 96 Boards Open Hours. Now we are about to start the after hours. So I guess we can stop recording now.